Good morning to all. Today we have Dr. Devashish Mitra, Group Director, Marine and Atmospheric Sciences Group IIRS, to deliver the lecture on the topic Remote Sensing and GIS for Coastal and Oceanographic Processes. Dr. Devashish Mitra is a geologist by profession. He passed his Master in Applied Geology and MTech in Engineering Geology from IIT ISM Dhanbad and completed his doctorate from ITC Netherlands in sandwich mode. Dr. Mitra is working with the Indian Space Research Organization ISRO for the last 30 years and presently he is the Group Director of Marine and Atmospheric Sciences Group at Indian Institute of Remote Sensing IIRS Dehradun. He is responsible for capacity building activities on remote sensing and GIS applications
Okay.
on ocean and atmospheric sciences at IIRS. Dr. Mitra has a vast experience on remote sensing and GIS application for coastal zone management, coastal hazards, and coastal geology and geomorphology. He has more than 130 publications in peer-reviewed journals, along with 12 chapters in international books. Dr. Mitra has guided more than 20 students in MTech and postgraduate diploma level. 5 students got PhD under his guidance. He has examined several doctoral theses from various prestigious universities in India. He is reviewer of several national and international journals and editorial board member of GI Science and Remote Sensing. He has delivered several invited talks in various academic and scientific institutes in India. So, with the brief introduction, now I request you, sir, to please deliver the lecture.
Okay. Thank you, Dr. Sachiko, for the introduction. Good morning to all the participants who are listening to the lecture. So today the topic of my lecture is remote sensing and GIS for the coastal and the oceanographic processes. This lecture is a bit different than the actual title of this course. I will be telling you more about the use of remote sensing for the various kinds of ocean and the coast. So you'll be always take you out of the ocean modeling from a bit towards the coastal region, and I will try to tell you how remote sensing can be used for various kinds of mainly the coast as well as the near shore coastal region. So let us start the lecture. Now I will just go with first few introductory slides, particularly what is the importance of the ocean, why we need to study the ocean, why conservation of ocean is needed. As you all know, the ocean makes up around 75% of the planet, and it provides various kinds of services to the human being. Like example, it generates oxygen, food, it stores excess CO2. Lot of weather events, they basically originate in the ocean, so it helps in mitigation of the various kinds of weather event. You all know about the cyclone, like even rainfall in our country, all controlled by the ocean. Increasing greenhouse gas emissions threaten coastal and marine ecosystem, but lots of greenhouse gas they are basically get absorbed by the ocean. And these greenhouse gases, they changes the ocean temperature, which may cause the coral bleaching. You all understand ocean acidification. This increasing greenhouse gas causes the melting of the polar and Antarctic ice. I was just telling ocean acidification by absorbing the excess carbon for the atmosphere. Because also ocean acidification, there are a lot of adverse impact on the coastal ecological elements. And because of the climate change, the global ocean is experiencing various effects of the climate change in the form of increase in the air and the water temperature. Because of the temperature increase in the ocean, it causes coral bleaching, so we lose the coral, and also it causes shifting of the various species. Because of the melting of the ice and thermal expansion of the ocean water, it causes the sea level rise. Because of this, it causes coastal erosion and also inundation of the near shore coastal region. This is all because of the rising temperature. Also, it has been seen there will be a situation called hypoxia. There's less of dissolved oxygen in the ocean because of the process called algal blooms, and which causes various kinds of marine diseases, loss of the fisheries, and loss of various kinds of marine mammals because of the hypoxia condition, which is called basically less oxygen in the ocean water. Also, because of the climate change, it caused the change in the level of the precipitation, the change in the frequency of the floods, droughts in the land region, and also the frequency of the storm surges and other various kinds of storm. And also, you have seen that of late, there are a lot of changes in the frequency of the occurrence of the cyclone, both in the east as well as the west coast of our country. Nowadays, we are talking about the blue carbon. Blue carbon, basically the carbon dioxide captured by the world ocean and the coastal ecosystem, which is very, very important. And this carbon is stored in the form of biomass and the sediments, which are coming from the mangroves, the tidal masses, and the seagrass meadows. That means mangrove, tidal marsh, and seagrass meadows are very, very important for the blue carbon aspect. The ocean basically affects the climate through its huge capacity of water and the heat. Ocean has 97% of all Earth's water, total water, 97% belongs to ocean, and 86% of evaporation happens from the oceanic water. The upper 3 meters of the ocean has the same amount of heat as the entire atmosphere. You can just imagine the amount of contribution of the ocean in the various kinds of environmental parameters. Absorb 84% of the heat from the global warming. So it is absorbing the excess carbon, it is absorbing the heat. That means without ocean, we don't have any existence. Because of the global warming, we all know now the global warming is happening. It is a reality, not it is a myth. Initially, when people used to talk about the global warming, so a lot of there are other groups that are talking, no, this is not correct. There is nothing called global warming. But of late, it has been scientifically proven that global warming is happening. From 1860, global average surface temperature is rising. 11 of the warmest year recorded since 1990 and 5 warmest year occurred in the last 10 years. So the global warming scenario is increasing day by day, and with increase of the industrialization, a lot of other various kinds of like air conditioner and lots of other apparatus what we are using, they are increasing the greenhouse gases. So entire temperature of the air is increasing, which basically causing the global warming of the Earth's surface. Average global temperature is rising about 0.6 degrees centigrade over the past century. And it has been accelerated during the last 2 decades, last 20 years, around plus 1 degree centigrade per century. If this continues, then the situation of our Earth is very, very alarming. Now coming to the coast, as I was telling you, I will be talking about the coastal region today, which basically a transitional area between the land and the sea. The red line you can see in the image, which is basically a transition. It's a part of the ocean, and part of the land is coming under the coastal area. So it is basically a zone. It's a band rather than a line. Line in the sense when we talk about the line, we talk about the land and water boundary, and that line represents in a GIS like a polyline. Okay, but coastal zone as such, if you digitize the coastal zone, it will appear as a area. And the width, the coastal zone, the width is not same everywhere. This width is varying from the place to place, and it is determined by the interaction of the marine and the terrestrial processes. That means if the marine process is very strong, it will push back the coastal zone deep inside the land. That means coastal zone will be very narrow. In vice versa, if the land process is very strong, it will push back the oceanographic processes deep inside the ocean. That means the coastal zone will be quite the coastal zone will be very narrow, and vice versa. If the marine process is very strong, then the coastal zone will be quite large. Coastal zone, the total area is very less. It is around only 18% of the Earth's land surface. So out of 100, only around 18 surface comes under the coastal zone. As I told you, it is a part of the land and a part of the ocean. And the width is varying from place to place. there is no constant weight. It depends on the interaction of the marine and the terrestrial process, and it is very, very dynamic region. Only 40% of the total 3.5 lakh kilometer of the coastline around the globe is accessible and temperate enough to be habitable. That means rest 60% maybe we cannot reach there, or they are not temperate enough that human being can stay over there. So only 40% we can reach, or the people are staying over there. But within this, total 18% out of that 40% of total coastline is accessible, but it accommodates around 60% of the world population. That means the area is less, total number of population very high. That means density of the population is tremendously high in the coastal area. And if you see around the globe, in India context, if you see all our out of 4 mega cities, except Delhi, Chennai, Mumbai, Kolkata, they are all lying in the coastal zone. And in around the globe, if you see from US to Europe, Australia, so many big cities, they are all lying in the coastal region. And it is so because our human civilization started from the coast. So we started living first in the coast, then slowly, when population is increasing, we migrate towards the land. That is why. And also there are a lot of positive side being in the coast, particularly, as you are aware that basically your transportation and everything starts from the coast. Earlier it was all voyage. There was no airplane. There is no good road or the rail network. Now also all the big trading, big ships, they all go through voyage only. That means the coastal zone or the coastal zone is the area where basically entire transportation and everything is happening today because their airplane is very expensive. All the cargoes you understand is very expensive. So huge cargoes, huge transportation path. Only the profitable way of to send by ship. And if we try to understand or summarize in few points about the coast, it is occupying, as I told you, 18% of the surface of the globe. 60% of the world population are living within this. Two-thirds of the major cities in the world lying in the coastal area. Population density is 6 times higher than the non-coastal region. 90% of the world fish catch is coming from the coastal water. Why this is so? This is so because the coastal water is highly productive. There are a lot of productive in the sense we talk about a lot of chlorophyll are there in the coastal water because in the coast the river comes and meet along the coast, and while meeting they bring in a lot of nutrients from the land, and the nutrients they dump in the coastal area along with definitely a lot of sediments. So that is why if we analyze the chlorophyll concentration in the coastal water, concentration is very high. And if you analyze any remote sensing data like our ocean color sensor data or the MODIS data, you can see in the coastal water the chlorophyll concentration is very high, and it reduces when we go towards the open ocean. And chlorophyll, the phytoplankton, they are basically food for the fish. So 90% of the world fish catch comes. As I already mentioned that coastal zone is part of the ocean and a part of the land. So 8% of the ocean surface comes under the coastal water. Also, the rivers bring a lot of sediments. 75 to 80% of the global sink of suspended river load is in the coastal water. That is why almost entire you can go and see in the coastal water is usually very turbid, except few areas like where coral reefs are there, like Andaman Nicobar, Lakshadweep, the water is very, very clear. And 90% of the global sedimentary mineralization are happening in the coastal zone. And why the coastal ecosystem is important? The dimension, let us see, it covers around 18% of the Earth's surface. Total length is around 3,56,000 kilometers. And in India, earlier our estimation was around 7,500 kilometers, but now the new estimation has come, including all small islands, and based on the latest data set, latest survey technique, our coastal zone is around 11,000 kilometers, total coastal length of India. 60% of the world population is living within 100 kilometers of the coast. So huge population of the world living within 100 kilometers of the coast. 35% Indians are living within 97 kilometers of the coastal zone. 10% of the world population are residing in the LECZ, that having elevation 0 to 10 meter. LECZ means low elevation coastal zone. I'm specifically mentioning this because this area is highly vulnerable for inundation. Like if there is a storm surge or there is a sea level rise, this region is going to be affected very fast. And 10% of our population means huge population is living in this narrow coastal zone. Like lots of coastal area of Bangladesh, Maldives, Fiji, India, Sri Lanka. So they are living in this elevation. So they are highly vulnerable for tsunamis, for the cyclone, for the storm surges, from the sea level rise. So we are highly concerned about this 10% of the world population who are residing in the LECZ. When resources is concerned, 120 million people of the world directly depend upon the coastal resources by various means, and 9 million Indians directly depend upon coastal resources, mainly by the fisheries, aquacultures, and other kinds of agriculture practices. When coastal biodiversity is concerned, it supports a huge number of flora, around 25,000, and lot of fauna, around 4713 fauna. Indian coast supports around 970 plant and 300 animal species. Many species are highly specialized and endemic in nature. Also, our coastal zone include economically sensitive areas, comprises wide range of habitats. Now we have a good coastal wetlands, um, and also the land wetlands. Coastal wetlands is around 43,230 square kilometer. We have 7 major estuaries. Particularly estuaries you will find in the west coast, and the east coast you will find a lot of deltas. Major lagoons, total 17. East coast we have 8 lagoons. West coast we have 9 lagoons. Total mangrove area, east coast we have a lot of mangroves, around 56%. West coast around 32%. And island area, Andaman Nicobar, we have around 12%. Total mangrove area is around 4303 square kilometer. Coral reef, we have around 1401 square kilometer. And mainly the corals are only few places like Andaman Nicobar, Lakshadweep, Pork Bay, and Gulf of Kutch. And we have around 6,200 square kilometer marine protected region. This is what we have when Indian coast is concerned. You can see we have around 9 coastal states and 4 union territories. The east coast is geographically divided called Utkal coast, Andhra coast, and Coromandel coast. And the western coast is the Malabar coast, Konkan coast, Kathiawar coast, and the Rann of Kutch. And these are the all coastal states like Gujarat, Maharashtra, Karnataka, Goa, Kerala, Andhra, Odisha, and West Bengal. So they are the 7 major coastal states. And we have a few issues in the coast, and then we'll address how remote sensing can address these issues. So you can see the Indian map, and a few numbers are displayed on this. And in the right side, in legend form, the numbers are talking about like issues like number 1 is the coastal erosion. So wherever you are getting the number 1, this coastal part is battered with the coastal erosion, and there is a degradation of the mangroves in the coral reef ecosystem because of a lot of anthropogenic activities. We are cutting the mangroves for setting up the industries, the urban areas like airport, or even sometimes thermal power plant. And also coral reef ecosystem is getting degraded day by day. Lot of natural disasters, we don't have much control, but they are still happening, and they are creating a lot of issues in the coastal zone like cyclone, saltwater intrusion in the coastal aquifer, tsunamis, storm surge. So there are the few major disasters happening in the coast. And there's one of the major issues is a huge population pressure. By now, India is now the most populous country in the world. So huge population is living in the coastal zone, and they are living because of the resources in the coast, and there are a lot of exploitation, a lot of conflict among the stakeholders in the coastal areas. Lots of industries are coming up, lots of hotels are coming up in the coast. So there are various ways of flouting the rules of the coastal regulation zone, and all because they are happening because of the population pressure. Population has to survive. They have to earn their bread and butter. They have to eat. So everything is happening in the coastal area. So coastal region or coastal region is in India particularly under tremendous pressure. Lots of ports and harbors are coming up in the coast, in the coastal region, and this is important for the national development. But we should take care. We should see. We should do proper environmental impact assessment before setting up the post. port, and also we should see the proper site selection where the port supposed to be there and what is going to be the impact of the cost of the setting of the port in the near future. So that there will be impact of the ports and the harbor. Lots of sewage like municipal sewage, wastewater disposal, industrial effluent, solid waste disposal, all the waste from the thermal factory, sometimes nuclear factory, agricultural waste, municipal waste from the domestic uses, they're all dumping in the coastal region. So the quality of the coastal water is degrading day by day. And because of this dumping, the fragile coastal ecosystem is affected. Coastal mining is another issue which aggravates the coastal erosion. We do a lot of like sand mining and other mining for building materials, for setting up our houses, which creates a lot of coastal erosion in coming future. Coastal construction, you already know, lots of coastal construction are coming up in the coastal region, and which creates a lot of negative impact at the coast. Number 10 point is the increase of the seawater. It's a very critical issue in various places of the coastal region because of the anthropogenic activities or sea level rise. It has been seen that coastal water is migrating through the aquifers deep inside the land, and also they are pushing back the freshwater head or the we call it the freshwater and the saltwater wedge. It pushed back by the seawater towards the land. Then what is happening? Like if you are living in the coastal area, you are getting fresh water for the last several years through your hand pump, but suddenly you are started getting saline water. That means what? That means the entire fresh water in the coastal aquifer underneath had been replaced by the saline water. Okay, so that means this is a basically subsurface geological processes, and it basically aggravates because of the unscientific ways of withdrawal of the saline water for various kinds of activities like aquaculture practices, like salt pans practices in the coastal region. So we do exploit the saline water near the coastal area, and more we do exploitation unscientific way from the saline water near the coast, it invites or it aggravates the saline water intrusion in the land part, and it pushed back the freshwater part deep inside the land. Because I have seen some lots of field work carried out in the Gujarat region, Bhavnagar coastal area, where it has been seen that saline water has intrusion has gone around 20 to 25 kilometers far deep inside the land. Another point of concern is the reduction of the coastal and the sediment supply. Basically, this is very important when coastal erosion is concerned. If there is a reduction of the coastal sediment supply by the various rivers because of the construction of the upstream dam, so all the sediments which the rivers are bringing, they will be getting filtered in the upstream side. So after the dam, only the water will be coming devoid of any sediments. When they reach the coastal area, enough sediments are not coming. Automatically, because of the sediment budget concept, the more scouring will happen near the coastal region, so more erosion will happen. So that has been mainly because of the reduction of the coastal sediment supply. And the last point is the impact of the tourism. So that is mainly because of the littering in the coastal region, like cutting the mangroves sometimes or taking the corals with them by the tourists. So they also leaving the plastic while they are roaming in the coastal islands or other things. So that they also create a lot of problems. So tourists should be learned enough. They should not destroy the fragile ecosystem like corals and the mangroves and other things. And they should not throw their plastic bottles and other things or food items in the coastal region. Now, when we talk about the coastal hazard, basically you can see the pictures. We talk about the flood, the coastal flooding, cyclone, storm surge, erosion near the coast, saltwater intrusion, sea level rise near the coastal region, land subsidence in the coast because of the coastal erosion sometimes. So these are the all happening in the coastal region. Few are very slow, like erosion, sea level rise. They're the chronic disasters, saltwater intrusion. It doesn't happen in 10 minutes or 5 minutes or land subsidence. But there are few rapid onset hazards like tsunamis, storm surge, flooding. So they happen very fast. Now, when we're talking about the remote sensing of the various kinds of coastal processes, let us see or try to understand what are the various parameters which can be retrieved from the remote sensing data of ocean. Like most, I think widely accepted and widely used, the parameter which is coming from the remote sensing data is we call the ocean color, or the amount of the chlorophyll in the ocean water. We call the microscopic plant or phytoplankton. The sensor, we have the ocean set series of sensor which gives you the ocean color, and wavelength range, and the sensor is written spatial scale, which scale we get the data, like ocean set data we get in the 360 meter resolution, and the other sensor like MODIS is there, and so many other sensors are there. So they gave also data in sometimes in 500 meter or 1 kilometer data. So the spatial scale we get around 250 to 1 kilometer data. And we have also in the last column, you can see I have written the interaction mechanism, how it happens. Mainly there are algorithm, and they mainly depend on the absorption and scattering of the sunlight by the sea constituent. Okay, and when our ocean color is concerned, though its spatial resolution is a bit poor, but the temporal resolution is very high. Every second day we get the data. So repeativity 2 days. So we get the data every second day, which can represent the dynamic behavior of the coastal zone. Another parameter is important called sea surface temperature, that we get from the microwave infrared radiometer and the microwave radiometer. You can see it is written in what gigahertz they are working and what of the wavelength of the infrared radiometer, and the resolution like no average error SST, basically resolution is 1.1 kilometer, so it ranges from 1 to 4 kilometer. Microwave radiometer we get 25 kilometer, and it mainly interaction mechanism, the emitted infrared from the ocean water and the microwave radiation, basically we study and get the there are certain algorithm to get the SST sea surface temperature from the no average error data. We get ocean wind mainly from the scatterometer data. We call the ocean vector. Their amount and the direction, that basically scatterometer works in the 13.5 gigahertz, and their spatial scale it varies again from 12 to 50 kilometer. And basically how the mechanism is mainly we measure the sea surface roughness, and which becomes translated to the wind speed and direction. So basically it's a process where the sea surface roughness is translated into wind speed and direction. We get to know about the ocean surface topography from the altimeter data. We have Soral Altica of our own altimeter, which give the ocean surface topography around 8 to 20 kilometer range. Also, we can measure sea surface salinity from the passive microwave radiometer in 1.43 gigahertz in 50 kilometer per resolution. And because this frequency is sensitive to salinity changes in the ocean water, so like sensor called one sensor named SMOS, so that give you the sea surface salinity. So we get to know the concentration of the phytoplankton, which will give you the productivity of ocean water, sea surface temperature, sea surface wind, SSW. We can get to know sea surface topography, CI, sea surface salinity. Also, we can get from the full parametric microwave data, we can generate the wave spectrum. Wave spectrum can give you information about the significant wave height, wave direction, wave speed. That also we can know from the remote sensing data. That means, does it mean that satellite can do everything? Is it enough? There are certain advantages of the satellite data, as you all know, that it gives you synoptic and repetitive coverage. In contrast to the sparse and the isolated in-situ data, we don't have so many instruments installed all around the vast coastal region. All the in-situ data are isolated and sparse. Few areas which are inaccessible to the sea, like very near to the coast. When bathymetry is concerned, very near to the coast, the ecosonic ship cannot reach because of the shallow depth. So in those places, only satellite data, using the satellite data, you can get information about the bathymetry. So few areas like few mangrove area where ship cannot reach, still you can get some information about the mangroves from satellite data. So few areas are inaccessible to ship, and other certain parameter like sea surface height only accessible from the satellite. But disadvantage of the satellite data, there are certain disadvantages. They mainly gives the surface measurement, but few definitely some institute, some information about the depth bathymetry you can get from the remote sensing. But majority is the surface measurement when SST, chlorophyll, these things are concerned. Some parameters are still not available from satellite. So all kinds of parameters of the ocean cannot get from the satellite data. And there is the issue with the spatial and the temporal resolution. As you know, the ocean channels were getting around 300-meter resolution. And then some places where temporal resolution is also very poor. So these are the all issues when ocean is concerned. Now you can see that we have a various kinds of integrated ocean observation system where we get the various in situ measurement data, which help you to particularly for the validation of the various parameters retrieved from the model or the satellite data. Like we have various kind of tsunami buoy, we have the wave rider buoy, we have high frequency radar, we have the Rama buoy, we have the Argos floating. So these are the all various kinds of parameters will give you uh, lots of information, particularly and which are helping to assimilate in the various kinds of ocean model. Um, like as in the first lecture, Dr. Nayak was talking about the ROM, POM, regional ocean model. So those kinds of model, this parameter can go inside. So these are the very, very important when calibration and validation is concerned. And these data are freely available from the different website. If you can see this slide, like Argos, that gives you the vertical profile of temperature and the salinity. Every 10 days you can get the data. Ramabui, various parameters, sea surface height, salinity, wave height and period, surface wind, high resolution data, daily data you can get using this. Omnibui, that give you salinity, currents, daily writer buoy. They're very important during time of tsunamis, wave period, direction, significant wave height, high resolution data. Like wave rider buoy, we get information in situ at the same time using microwave data, but like data set to fully permitted data, you can get this information. So you can always calibrate your model using this information from the wave rider buoy. High frequency radar that gives you surface current, significant wave height, wave period, direction, hourly. Tide gauge give you water level data hourly. And there are a lot of research vessels in India by a lot of scientific organizations like National Institute of Ocean Technology, National Institute of Oceanography, NIO, Geological Survey of India. So they have a lot of research vessels. And they do go for the sea cruises and get a lot of information, which also helps for calibration and validation of the ocean model, like Sagar Sampad, Sagar Kanna, Sagar Nidhi, Sagar Paschim. Lot of sea vessels are there, and they go in the sea cruises. And we have a Calvel site, calibration validation site in Kavaratri in Lakshadweep. And you can see I have written the few websites. These websites will help you to get all those buoy information and the other data set which are freely available. Like there is an organization called Enquest. Enquest, lots of buoy data is available in the site. You can download the data, and also from the NOAA site, you can get lots of information around the globe. You can see when we talk about the various kinds of ocean parameter, various kinds of coastal zone activities. It basically how we look particularly at what scale you need to derive the map. It depends on the what kinds of spatial resolution you need. You can see from the left top, if you see there is a satellite data. It's a NOAA Voyager data 1.1 kilometer resolution in the Gulf of Khambat area in the Gujarat. Where what you can see the land is coming in the black color and water is going in the form of a gulf. That much only you can see. But when this box, when I'm seeing in a IIRS OCM data 360 meter, at this you can see all the rivers they're coming and meeting. You can see the vegetation red color or the salt pans white color. You can see lots of estuaries. You can see the Sabarmati. You can see the Tapi. You can see the Narmada. You can see the Mahi. All rivers are coming and the meeting. So that much you can see. Then, but when I'm again seeing the same part, some part of this region in the A waves 56 meter, or list 23.5 meter, or list for 5.8 meter, or even better resolution cartosat or list for March 2.5, or after that even you can go for some foreign satellite data, some iconos of the quick bird data of resolution of in centimeter scale. So your interpretation capability will be increased. You can see in the list 3. Okay, I can find out the mangrove and other things, vegetation. But when I'm seeing the same part in the list for data, You can see the some port structure, detail the human habitation, the agricultural land, everything is very clearly visible. Clarity will be increased or more features will be able to identify when I'm going for a 2.5 meter resolution, more features is coming up. That means if I want to generate a map of 1:50,000 scale, maybe your uh, uh, list tree data is good enough. But if I want to generate a small area, very detailed study, then I need to go for the Kato or the list format data or the Kato set data, where I need to generate a map of 1:10,000, 1:5,000 scale. That means what resolution data you'll be using depending on the finally what scale you want to generate the map. In this slide, I will just try to show you that how the mangrove has been cut and the aquaculture farming has been started in the Kakinada coast in the Odisha. You can see it is the all the red color mangrove is the Kolinga mangrove near Kakinada Street, where you can see the black color square. They are all aquaculture, and aquaculture has come up cutting the mangroves. And this whitish color, they are the basically ancient aquaculture. Now they are not being practiced, so they are the all dark blue color that the aquaculture plant filled with the water, and they have come in the cutting the mangroves. But mangroves come under the CRZ1 coastal regulation zone given by the certain regulation by Minister of Environmental Forest, passed by our parliament. It's a law. So as per that law, you cannot cut the mangroves or alter the sand dunes or converted the mud flat. But you can see how the laws in our country has been flouted, and for the money earning sake, basically, I will say how the mangroves have been cut and aquaculture practice is happening. So that is the beauty of the remote sensing data. If this type of things are happening only from a satellite data, you can see whether the aquaculture is still being practiced and not. And in GS technology, I can find out, I can digitize all the aquaculture land and I can find out what is the total area. So this is a data of I think 2003. Now, if I get a data of 2005 and find out the area, like if this area is X square kilometer, and then if the latest mangrove area is Y square kilometer, if Y is greater than X, that means new aquaculture practice has come. But the ruling given by the our apex court, the Supreme Court of India, that no new aquaculture will be practiced cutting these mangroves and other things. That means that then we are not following the rules of the country. So those things, remote sensing data can very easily picked up, and this information or this image can be a very vital proof in the court of law, particularly. I was talking about the regulation June 1999. It has been given. After that, there are some changes. Some new committees have been set up. But this was the first regulation when you came in the year 1991, where entire Indian coast has been divided into four regulations: CRZ 1, 2, 3, and 4. CRZ 1 is the ecologically sensitive areas and the areas between high tide and low tide. No construction is permitted in the CRZ 1. And this particular coastal regulation zone, the area is the area in between high tide and low tide, and 500 meter from the high tide line towards the land. So the entire region, 500 meters from the high tide line towards the land, and the high tide and the low tide comes under the coastal regulation zone, which has been divided into 1, 2, 3, and 4. One is the ecologically sensitive area, no construction permitted. Ecologically sensitive areas means all the sandy beaches, dunes, mangroves, coral reefs, mud flats, coastal protected areas, they all come under the CRZ1. CRZ2s are the areas already developed close to the shoreline. Before the regulations came, there may be some coastal towns, coastal villages which are already developed under the CRZ2. After the regulation, we cannot destroy them, but now certain regulations have come. If you want to, like if you have one-story building, if you want to set up a second-story building, so which part of the ocean you should set up the building. So in Government of India Gazetteer of the Rajpatra, all the regulations they are giving what are the permitted and what are the prohibited activities in the CRZ region. You can get into the net and you can download all those information. CRZ3s are the areas which are relatively undisturbed, and those areas which doesn't belong to CRZ2 and the 3. And CRZ4 are the coastal stretches in Andaman and Nicobar and Lakshadweep and all of the small islands. I will just give you a few examples where the norms of the CRZ has been flouted. Like industrial growth in Gujarat has damaged the CRZ-1 in Gulf of Khambhat and Saurashtra. Mudflood in the Maharashtra and Kerala is reclaimed for agriculture, industrial, residential, and agriculture use. Salt harvesting and aquaculture development are responsible for the damaging the mangroves of Tamil Nadu, Godavari, and the Kisan region, also in Sundarban. Mangroves have been cleared for the harbor activities near the Paradip port. There are only few examples. There are so many examples in our country where the CRZ norms has not been followed. But there are certain issues. All the state didn't agree with the CRZ, so Government of India set up different committees like Swaminathan committees. Then the latest one, the Soilis Naik committees, and those committees had given different recommendations, and maybe in future different regulations will come and they will be passed by a parliament, and there will be the laws and the people will follow that. Another important parameter is called the soil line delineation from the remote sensing data, which is very important because soil line is very important in the sense then only you will be able to understand how much is your coastal area. For various kinds of quantitative analysis, soil line is very important. And in our country, considered under the CRZ, you should remember the high tide line, HTL, is considered at the soil line. And where 2011 notification, it has been told that HTL is a line on the land up to which the water reaches during the springtime. This is the definition of the HTL, where the water reaches during the springtime time. And in the field, if you want to find out the HTL and try to validate from the satellite data, what are the things we look for? We look for the permanent vegetation. You can see the image up to where there is a permanent vegetation, then the land start. So water may come up to this. So then landward berm. This is the HTL. Seawall, top of the seawall is the HTL. Top of the dune, during spring tide, water will come only up to top of the dune. So top of the dune is the HTL. Base of the cliff is the HTL. Landward boundary of the mangrove is the HTL. So these are the features which you can identify from the field. And then finally, you come back, you digitize these in the field with a kinematic GPS. Then if you see from the remote sensing data, get the land water boundary using various indices like NDWI and other things, then try to match it. How accurate is your land water boundary from the remote sensing. So this is a few examples what I am telling you, HTL and identification of the satellite, and the entire Indian coast, the HTL identification of remote sensing has been done and atlases have been prepared. Now, when we talk about the bathymetry, particularly, as we know, the multispectral satellite data has different bands like blue, green, red, NIR, TIR, SWIR. So different band has different penetration capability. Red light attenuates rapidly in the water, doesn't penetrate deeper than 5 meters. Blue can go up to 15 meters. In clear water, it can go up to even 30 meters. Green light penetrates as far as 15 meters in clear water around the corals. NIR has a penetration capability only up to 0.5 meter, and the IR is fully absorbed. That means if you want to develop certain algorithm using multispectral satellite data for the bathymetry estimation near the coastal region, basically only two bands which are very important. That is the green and the blue, and it has been seen from the very beginning when the scientists tried to understand the bathymetry by using remote sensing data like Lysanger principle, like Stump's theory. They all work with the green and the blue light. After that, lots of people using machine learning languages to understand bathymetry of satellite data. But remote sensing data is very, very crucial and important to at least update the nature chart, national hydrographic chart for near the coastal region where their eco-sounding ship cannot come very near to the coast. So in those areas, satellite remote sensing can help particularly to get some information about the bathymetry using blue and the green. Another important aspect of the remote sensing, I should tell you that NIR or the IR is almost absorbed by the water. So if you want to find out the land or water boundary, if you load the simply NIR band, so entire water part, if the water is devoid of any suspended sediment, the water will absorb the NIR band. So pixel values will be very less, and the land will be reflected with the NIR. That means the land and water boundary will be very, very clear. So you can digitize very nicely with less error. So that is the advantage of the NIR band for finding out the land or water boundary. And also NIR is important. It talks about the it gets reflected in the vegetation. So that's why the NDVI, normalized different vegetation index, we also take help from the inner band. So inner band is very, very important. So there are various parameters, like as I told you, ocean, like coast, also various kinds of parameters we can get to understand from the remote sensing data. I'm not going in detail. Like you can see the about fisheries information, coastal geomorphology mapping we can do, upwelling area, the eddies in the Gayat near the coastal region can be identified from remote sensing data. Coastal regulation zone, entire Indian coastal regulation zone has been mapped in different scale. One is to 50,000 and one is to 25,000 scale in selected areas using remote sensing data. Oil slick study, which is one of the important pollution aspect, using microwave data, and also optical, high resolution optical data can help you out for oil slick study. Chlorophyll, as we have already told, this chlorophyll study. Soul line changes, how the soul line changes with the time, that can be mapped using multi-temporal satellite data. So there are so many parameters which can be mapped, so many processes of the coastal zone which can be studied by the remote sensing data. Only using some multi-temporal satellite data, I will just try to show you like how it can help you out to understand how the various coastal scenario is changing with time. So this is a mangrove patch in Bhavnagar coastal area in 2000. You see the red color. This is a Bhavnagar Creek. The blue creek is going towards the land, and this is a mangrove patch. You can see that this is a 2000 image where the eastern part of the creek, the mangrove is very thick, but the western part of the mangroves are very scattered. But after 8 years, when I am taking the satellite data, IRS history data, in the same month in 2008, after 8 years, I can see that in the eastern part of the creek, the area of the mangroves are decreased. So a lot of mud deposition has happened over the mangroves. But the western part of the creek, mangroves has increased. So there must be some reason that what is the reason, we should go to the field and try to understand. But at least from the remote sensing data, we will be able to see there are certain changes has happened in the mangroves in the 8 years time. Some part the mangroves has increased and somewhere the mangroves have decreased. So this much I will be able to know. Just I was telling you the soul line changes. So soul line changes is also another important parameter which can be understand through multi-temporal satellite data. Here what he did, we digitized the soul line from surveying the toposits surveyed in the year 1920 and 1930, and in the backdrop we put the image history of 2001. So there is a gap of around 70 years. Then you can see the how the things have changed with time. You see the blue color, the yellow line is the soul line from the SOI 1930, and the backdrop is the image of 2001. You can see there are a lot of changes. New island has come up, new barrier island. The speed changes in the speed. So here is now the speed, and the earlier the speed was here. Here the erosion is happening. Here accretion is happening. Here the Paradip port has come. So this is the in 2019 the land water boundary was here, the blue line. But in 2001, this entire part is covered with water. That means the entire land part has gone. That means this is the erosion region. Here the reverse has happened. Now the land water boundary is here, but earlier it was the yellow line. That means the new land area has been deposited. So here this is a part of this accretion. So some part of the southern part of the Paradip port, some accretion is happening, but in the eastern part, lot of erosion has happened. So that means the coastal zone is very dynamic in the Mahanadi estuary in the Odisha. New island is coming up. The speed is changing its shape. So many things are happening, which can be very well be detected using multi-temporal satellite data or satellite data and the survey window toposit rectified together. Now, also there are certain techniques we can identify. Now, in the earlier image, we were talking about the yes, erosion and accretion is happening, changes, but we can quantify those changes, whole line changes. The certain statistical techniques are there. Just I will try to mention so that you can help you out. You can do the better work, in-depth work. There is a software called digital soul line analysis software. This is the freely available with the ArcGIS software. It is an extension of the ArcGIS software. You can load it. And also now this has standalone module is also available. Without ArcGIS also you can run it. So there are certain kinds of modules are in between dishes. We call the EPR endpoint rate, which calculates the rest of the changes in position between the oldest and the most recent soul line in a given data set. Basically, in the DISA software works with the various time series analysis of the soul line. So you need to collect uh, maybe last 25 years soul line from satellite data. Then this type of analysis can be possible. Linear regression net side event movement. This is the distance between the youngest and the oldest soul line. Linear regression rate is the average rate of changes using a number of soul line position over the time. Only one thing you have to remember, whatever the image you will be using, you should use the soul line extracted at the same tidal level condition. So same tidal level image you should use. And here, then after using this technique, you will generate a map like this type of color, where the positive values indicate accretion and the negative values indicate the erosion. So whatever the positive values, the green color here you can see over this. This is a small island in the Bay of Bengal in the Sundarban region. The green color represents the erosional region. The red color particularly where the accretion is happening, and also you can quantify. The software will quantify how much erosion has happened. It will tell you even the rate of the changing of the erosion, and you can also find out the region where erosion accretion is happening. So this is a very good techniques. Lots of papers are being published using this. Also you can work. You can see we did lots of work using Bengal coast, using EPR, endpoint rate, and various region. The minus values, you can see the red one. Here, this is the Sagar Island, and then the other island, mangrove region, where the red color, where erosion is predominant, and the green color for positive values, where accretion is happening. So that way you can generate the maps to understand erosion accretion. And also in here is a provision to find out the future soul line prediction. This is based on the historical soul line position. That it basically how it works. It basically works how your earlier soul line is changing with time. Based on that, the DISA version 5 can calculate a forecasted soul line. So based on all the parameters, how the future soul line is changing, it can predict how the in future how the past soul line is behaving. So it can, using those features, you can predict how the future soul line will be predicting, and this will be in a 10 or 20 years into the future. That means if your last soul line is 2025, you can predict 2035 and 2045. It is like this. And the techniques, it use some Kalman filter to combine observed and the model derived position. This methodology assumes a linear regression through the past positions as a good approximation for the future soul line position. So it all depends on how your past soul lines are behaving. Like you can see here, the forecasted soul line for the year 2034. So the latest soul line we use 2024. You can see we use 20 soul line 2000, 2005, 10, 15, 20, and 24. Then future soul line predicted 2034. Okay, so the black line, how in this region, how the future soul line is going to behave, and how accurate they are. Also, there are certain techniques you can find it out. How accurate is your future soul line prediction? So this is the entire Indian coast. We have predicted the future soul line. You can see the various region. This is the West Bengal coast. Same way we did it for the Andhra coast, the Odisha coast, the Tamil Nadu coast, and the other coastal region, Maharashtra coast. Entire India we have done. And few area you can see the matching. The predicted soul line 2024, how it matches with the actual soul line. Few places it matches very nicely, but there are certain differences we will find where the soul line is highly granulated and there are a lot of islands and the mangroves, those things. Then there will be certain variation, and you can find out the what is the percentage of similarity is there within this soul line changes. Basically, there is a called the cosine similarity, which is a metric that quantifies how well the predicted soul line follows the overall trend or shape of the actual soul line. You can see the similarity percentage. Tamil Nadu, Pondicherry, Andhra coast, it was around 60 to 70%. Odisha coast, there are a lot of island and the mangroves are there. It is around 53. Bengal coast also islands and mangroves are there, so it comes around 60%. But when you remove those regions, particularly all the climate part of the coast, if you make only the linear part of the coast, the similarity percentage increase even up to 82%, 77% like this. See, all other region when you use the like speech, mangroves, island, if you remove, then the similarity percentage increase. But overall, if you do this techniques, you can get at least 60 to 70% similarity about the future solar. Now, I will talk about a little bit about the your potential fishing zone, which is basically techniques from the remote sensing, how the fisherman can go to the catch the fish, taking the information from the remote sensing data, and chances of getting fish are more. Say earlier, the fishermen go with the traditional knowledge like bird congregation, color, bubbles barking on the surface, muddy on the oily water, reflection in the night. So they are the all techniques they used to go. And the success depends on the fisherman's keen sense of sight, smell, and hearing. Often, the fishing trip resulted in spending longer days at sea, return with low or the no catch. Okay, a good catch was only expected at the luck of the fisherman. But now, as the situation has changes, nowadays we can get the like food for the fish. Earlier told the information about the chlorophyll. I can get information about the temperature because fishes are also very sensitive to temperature. Once I get the information about the SST, about the chlorophyll, we can make a superimposed, and also we get the information of the SSW. We put them together in the geophysical technology, and we can generate the potential fishing zone. And all those maps in a real-time manner, we used to send to the fishermen, and they go with a GPS and try to catch fish in those regions. Like see. We first generate the chlorophyll map, SST map, and SSW map. Chlorophyll map from the OCM data. There are certain bioptical algorithms for the OCM imagery, no amateur data, split window techniques that give you SST, quick scut data. Then we retrieve the wind vector. They give you sea surface wind map, composite, PFZ composite map, and how they are disseminating. The advisor is prepared in the local language, and local measurement unit were disseminated thrice in a week, Tuesday, Thursday, and the Sunday, during non-band and the cloud-free region. And dissemination of the information through the innovative measure like electronic display board like this, in the fishing harbors, radio, print media, email, telephone, fax, in the local languages, the information is given to the fishermen before they go and catch the fish. You can see all the information. This is the SST map. This is a chlorophyll map. But you should remember the chlorophyll and the SST, both the images should be almost the same time. And we also try to look from the no amateur data, the thermal image. We try to find out the thermal font in the upwelling region. Upwelling region are the region from where from the bottom ocean comes and meet with the top cold water. And the bottom water, basically the rich will be a lot of nutrient. So those region particularly, you can see the meandering, the upwelling fonts, rings and filament. They are the region basically where the bottom cold water is coming and mixing with the upper warm water. So there will be a thermal font, and we from the SST we are trying to look for the thermal font and the upwelling region. Those regions are basically rich in the phytoplankton, and they are good for the fishing grounds. And there are a lot of validation has been done. Few ships went to the non-PFZ region, and few ships going to catch the fish in the PFZ region. Statistics have been given, generated by the Fisheries Service of India. It has been seen, like I can show you certain examples, like the fish, the fellow who went for the PFZ region, their net profit is around 2,82,000 rupees, when non-PFZ area is 68,000. And see the total catch. Total catch is in kilo. And in the PFZ region, 7,200, non-PFZ is around 1,800. So that means PFZ map is one of the finest example of the remote sensing technology which can reach to the grassroots level, and it has increased the quality of the life of the local fishermen who used to be very poor. But nowadays the things have changed. And also we have a very illustrated future plan for the potential fishing zone. This methodology is around 80% success rate. In the near future, the PFZ forecast will also harness the information on the sea state, the tidal currents and the wind, which will help the fishermen to reach the PFZ site safely. It is not that I will give you the PFZ map. We will be able to tell you how we will reach that particular point safely and in the shortest time. Now the fishermen are requiring, they are asking for the species-specific forecast based on the individual species, food habit, and the environmental condition. This will allow the fishermen to select the most suitable vessel, gear, and the fishing technology. If some fishermen is important for the tuna fish, they are telling us that you only give us the tuna information system. Because if I know beforehand that I'm going only to catch the tuna, accordingly I'll select the vessel, gear, and the physics technology. That is also possible using remote sensing technology. And also now experiments are underway to provide forecast straight to the fishing vessel. So when they are going to the directly from the satellite radio, the PFG information will reach to them. I was just telling you that certain study has been carried out using bathymetry from the remote sensing we can do. So this is the NHO chart. These are sentinel data in a Goa region, and certain techniques like I was telling you Lysenga, which is called the linear transformation algorithm, the ratio transform method by Stump, and the support vector machine. So there are lots of algorithms are available, and using those algorithms, the bathymetry map has been generated, and you can see the how they are related, how they are accurate, how accurate from their predicted depth and the actual depth from the NHO chart. So, and the regression values are around 0.7, 0.8, something like this. And it has been seen the Asper value support vector matrix is 0.82. That means the compared to the stumped root transform method or the linear transfer algorithm by Lysenga, the support vector machine SVM predict bathymetry better than those two. So, what are the published this paper that support vector machine works well when bathymetry from remote sensing data is concerned. You can do study. I will show you the few case studies very fast, which time is almost over. Like you can do the inundation study due to sea level rise. You can generate various scenarios. If you have a high resolution DEM, you can find out what are the areas which are going to be inundated if there is a rise of sea level of like 0.5 meter, 0.1 meter, 1 meter, 1.5 meter, 2 meters. So you can find out, and you can also superimpose the land use requirement to find out what are the areas which are going to be affected because of the sea level rise. Also, we did some study by we call the coastal vulnerability index. What are the various kinds of, because of the various kinds of oceanographic processes near the coast, there are few areas which are vulnerable. There are few areas which are not vulnerable. So throughout the world, you can see lots of people have worked on the coastal vulnerability. So they are a very important region, and lots of parameters people have considered, like coastal geomorphology, coastal slope, shoreline changes during the recent years, tidal range, significant wave height. In the Bangladesh coast also, we did certain work. The paper has been published in a high impact journal. Like we considered geomorphology, coastal slope, shoreline change, sea level rise, mean tidal range, bathymetry, storm surge height, and certain parameters. Their weightages have been given, like very low, low, moderate, high, very high, and the vulnerability index. You can see the formula. This formula has been used. CBI is going to root over of A, B, C, D, E, F by 6, and the A, B, C, D, E, F. They are the geomorphology, coastal slope, shoreline change, and out of these, majority of the parameters, geomorphology, slope, shoreline change, bathymetry, these all you will get directly from the remote sensing data. Few in situ observation definitely we collected from some department of Bangladesh, and we did this study, and entire Bangladesh coast particularly was you can see the some part of the Bangladesh coast they have been divided using coastal vulnerability index, very low, low, moderate, high, very high. Like this, you can find it out. Okay. We did certain study for the remote sensing GIS for the tsunami, for understanding the tsunami. And also, there's another important area. This is my last slide. I want to tell you. Also, there is a possibility that when not much work has been done to understand the digital elevation model of the intertidal coastal zone. We have a good elevation model in the other part of the land, or a bathymetry model, but only the intertidal zone, that region which used to be under the water during high tide and get exposed during a low tide time. Whatever the elevation of that, where is the DEM of that particular region? That study has been done. That study has been carried out over here in a small case study mode in some island in the Kalvar Island in the Gulf of Kutch. We did this work and we published this work, and the algorithm which has been developed has been shared with the concerned organization who can go in a regional scale mapping, entire Indian level DEM of the intertidal zone. Like example, I can give you the Australia. Entire Australia, the digital elevation model of the intertidal zone they have developed. So which is very important to have this. This we have done. We have done it, and you can find it out how the intertidal DEM has been generated, and certain simulation has been done using this from the DEM. You can see at the low water how the water, when the water is received from towards the ocean, what are the island get exposed when the high water, what are the, when water are coming, some island are getting submerged. uh, so this is the animation of the DM of the intertidal zone. So this is a case study basis, a small part we have done and we have published it. The software has been written in Google Earth Engine. So I hope that some in future somebody will take up and do the entire India DEM of the intertidal zone. So I'll stop here. Thank you very much for your patience listening.
Okay, the question in
Okay.
that one.
Okay. Yeah, there's a question somebody asked that how can data from satellite
Now you can. So,
Okay, fine. So there is a question on the how satellite based advanced very high resolution radiometer sensor to be used to identify oceanic thermal fonts. And no average data basically give you though resolution is poor, but it will give you um, uh, the sea surface temperature. Actually, earlier when we started working on the PFZ, National Remote Sensing Agency, those days, they used to use the no aperture data and generating the SST, because that time our OCM1, OCM2 was not there. We didn't have any information about the quantitative estimation of the chlorophyll. So we used to generate the PF generator based only on the SST image from the no aperture data. And we are only working, as I was showing you, only based on the where are the thermal fonts are there, not with the chlorophyll, because thermal fonts, upwelling region, gyres, the filaments, they are the region where the upwelling regions can be identified in the SST, because where there is upwelling, as I told you, from the bottom, the cold water will come and mix with the upper warm water. And when from the bottom the water is coming, they will come with, usually they come with lot of nutrients and temperature is less. That means there will be a zone of colder zone within the warm ocean water, and that is called the thermal inversion. So that basically picked up very nicely using no aperture data, and that area usually rich with nutrients. So basically we get good PFZ area. I'm in the class. I'll remove it now. So that basically we get we try to identify the thermal fonts through the thermal immersion, because this region, if you go by pixel wise, the pixel has certain temperature, and suddenly temperature drops at that pixel. Okay, then it will be again high. So that boundary we call that thermal font. We try to identify the thermal font from the no aperture data. So that is that. That's why how it is identified during those days. After that, anyhow, we got the OCM. Then we incorporate OCM along with the no aperture temperature. But now anyhow we have our own temperature, we have our own chlorophyll, so we use our own sensor. We don't use now the foreign sensor for PFZ. Somebody asked me, is there any special precaution to be taken while installing desalination plants in coastal region in metro cities. Any satellite data studies can be referred. Actually, I have not worked on this, but I can tell you, Sandeep, that this work has been done by an organization called National Center for Coastal Research, NCCR, uh, in Chennai. That comes under directly under the Ministry of Arts Sciences. So you can refer the earlier director, Dr. Ramana Murthy. He basically involved in STP plant in coastal region in Lakshadweep. So he is the right person to give you much idea. So you please be in touch with Dr. M.B. Ramanamurthy of NCCR, Chennai. How do study affect tidal change in tidal pattern on waves due to construction of coastal roads? How to study? Okay. How to study if a change in the tidal pattern on waves due to construction of road? Yeah, definitely that you can do very well from remote sensing data, particularly, or but for this you need to go for fully polarimetric microwave sensor data, as for example like RadarSat 2 or our latest RISat data, where you can generate the wave spectrum before the construction of the road and after the construction of the coastal road. Basically, when you construct a coastal road, it disturbs the uh, wave energy because of that construction, so it changes the wave pattern, and that pattern can be very well recognized from the wave spectrum. So before the road, what are the wave spectrum using fully polarimetric microwave data, and after the road constructed, how the spectrum has changes. Spectrum changes means that the shape of the spectrum will change, so you will get different wave direction, different wave period, different significant wave height. Things all will change because of the construction. That can be picked up very nicely using multi-temporal satellite data or microwave satellite data, active sensor data, which helps to generate the wave spectrum. That you can do that. Arindam, how will you use the remote sensing to track and understand the dynamics of phytoplankton bloom and the impact of marine ecosystem? To understand the phytoplankton bloom, remote sensing is very, very important. A lot of work has been done using phytoplankton bloom. Basically, the phytoplankton bloom will happen when there is a sudden increase in the nutrients in the coastal water because of certain kind of pollution, whether it is coming from agricultural land or other region. So various kinds of algal will grow very fast, and like plasmodium and other kind of algae, and when they will die, the bacteria will take the oxygen from the water, from the ocean water, to decompose them. So there will be aphoxia situation will be generated because dissolved oxygen will be reduced, and because of the decrease in the dissolved oxygen, it will impact the marine ecosystem in the form of lot of fish will die. Suddenly you will find where there are the algal blooms, which can be nicely picked up from the optical sensor data. Lot of fishes, the die fishes are floating on the ocean water at a certain place, and it has been seen in a particular region. Like there are a lot of case study using ocean color sensor data, like some part of the Gulf countries, where every year this type of algal bloom is happening, which has been find it out in the periodically using multi-temporal data. Different year, same things are happening at the same particular time. And in Indian context, we have been seeing that particularly where the region where there are chances of agriculture waste and the other waste are there, or the domestic waste, where the water is coming with lot of like nutrients, like phosphorus and other things, which enhance the increased growth of the this type of algae, which can be picked up their abundance by the remote sensing data. And at the time of the decay, they took a lot of oxygen from the water. and that creates the hypoxia situation, which basically causes the death of the various kinds of fishes, and it impact marine ecosystem. And the next question is, what is your take on cloud burst? Any radar to detect, because it is quick phenomena? How it see how to take the cloud burst? Any impact? Anyhow, though this is not directly comes under this study, but still I will tell you that because cloudburst phenomena is mainly happening in the Himalayan higher reaches. Now we talk about mainly the ocean and the coast, but this anyhow being in Dehradun, recent cloudburst event we are also studying, trying to understand. Here in this region, basically cloudburst incident, it is very difficult to forecast. Recently, certain incidents in the Dharali and other places. So even what is the actual reason, whether the very high rainfall or cloudburst or like globs or glacial bleaches, it is even still it is not scientifically proven. We also try to understand from the various kinds of analyzing satellite data, microwave data, optical satellite data, high resolution data, but still actual reason so far also we will not able to told, even not even Wadi Institute of Human Geology and other organization. But if would have been Doppler weather radar in a very high frequency Doppler weather radar throughout the Himalayan belt, then I think it would have been easier to forecast the cloudburst event. But without but right now Indian Meteorology Department doesn't have so high frequency DWR radar around the Himalayan belt. So and few DWR they have installed near a place called Dhanolti in Mussoorie, but sometimes it is working, sometimes it is not working. So right now we don't have any technology, and all the models, particularly for the forecast model for the rain forecast, other thing that their scale, the cloudburst even is a very in a small place, small village, in a particular area, small area, which can be picked up by the regional model. The scale of the model, the 1 pixel, it is in kilometers, 10 kilometer by 10 kilometer or 20 kilometer, 20 kilometer. That will not able to pick up the cloudburst incident, because this is it happens in a very small place, sudden huge rainfall in a small village. Then it creates a havoc. It creates huge flooding, and it goes in the downstream and does a lot of devastation. But when we talk about the forecast of the cloudburst, I don't think that we are in a position. So for the cloudburst, it's like an earthquake kind of thing. What I feel, we are not in a position to forecast cloudburst in the Himalaya region, unless until definitely unless until we have a very high frequency, like at least every few kilometers we have a DWR radar installation. Then only we will be able to will pick up the cloudburst event, along with the various kinds of sophisticated models which Indian Meteorology Department are already doing. So now last question is how to investigate AD filament and ponds modulate nutrient transport in upwelling region. In I'm not expert in this, but only from remote sensing, what we have done so far, only we can pick up the upwelling region. But in upwelling region, how the eddy filament and the fonts modulate nutrient transport is happening, the maybe remote sensing will not able to help much for this. Definitely some model, some field work, some analysis is needed, but I have not done any work in this region. Only what for the PFZ, definitely we have done quite a lot to find out the upwelling region from the SST image. Thank you very much.
Yeah, thank you, sir. Thank you, sir, for delivering such a very informative lecture, and it's a wonderful session. And tomorrow lecture is also planned, so the same time, 11 o'clock to 12 o'clock, by the using remote sensing and numerical modeling.
Okay. Thank you, Jonathan, and thank you all the
Thank-
participants.
Thank you.
Okay.